Hi everyone. In today's challenge, we are going to solve this problem. The problem name is maximum number of achievable transfer requests, and the problem number is 1601. Alright, guys. So as usual, first of all, we are going to clearly understand this problem statement. After that, we are going to move to the logic part. We are going to see how we can solve this problem. What is the logic to solve this problem? And after that, we are going to move to the implementation part. We are going to implement our logic in C++, Java, Python, and JavaScript programming language. Fine, guys. Now let's quickly see what this problem says. Right. The problem says we have n buildings numbered from 0 to n minus 1. Alright. Each building has a number of employees, its transfer season, and some employees want to change the building they reside in. Right. So, guys, simple thing we have n number of buildings. Right. There are n buildings. So, let's write a n buildings. Fine. And here the labels are nothing but 0 to n minus 1, right? So fine. And after that, in each buildings there are some employees. That is also cool, right? Now that employees want to reside or want to change their building, right? I hope it makes sense. So let's say there are four buildings. So let's say building 1, building 2, building 3, and building 4, right? Now there are some employees in each building, right? Let's say there are some employee 5, here 6, here's 4, here 3, right? They want to now change their building, right? Okay. You're given an array request where request of I from comma 2 represent an employee request to transfer from building from I to building to I, right? Simple thing, guys. Now let's say the one employee from building 1, here let's say this one employee from this building want to change their we can say want to change his building from this building to, let's say, this building, four building, right? Now what I mean by here, that one employee from this building want to move to this four building. So how will this array will look like? This array will look like 1 comma 4. That means an employee want to change from a building 1 to building 4, right? Want to transfer or want to move from building 1 to building 4. This is array look like, right? Same thing they are given from to 2. So from one building to four building, all the buildings are full, so a list of requests is achievable only if for each building the net change in employee transfer is 0. This means the number of employees leaving is equal to the number of employees moving in. Now, guys, what they means, guys, they means here, they means like all let's say in one building we have only 5 rooms, right? So that means all these old buildings, whatever the buildings given and buildings are already full, right? There's no empty room available, or we can say there is no empty block available, right? So an employee can only transfer to that building if an employee is also moving from that building, right? This one employee from this one building can only move to this four building if this employee are moving to any other building, right? I have it making sense. Let's say this one want to move to this four building, so this any employee from this four building also should move to any other building. Then only that employee can enter in this building, right? Otherwise the space is already full. This employee cannot insert or cannot transfer to this building, right? Now they have given same example, if n is 3, so on, so on. That don't we don't need to see that. Now the last thing is return the maximum number of achievable requests. Now we have to return the maximum number of achievable requests. Means we can achieve, we can move that particular request, right? A request nothing but we can say a request array. This we have seen from twice. So we have to return maximum number of achievable request. Means maximum number of people can transfer from a given from their building to any other building, right? So let's see with example, then you can have better understanding with this problem. So here we have this example, right? So you we have request is nothing but this array, n is equal to 5. That means there are total 5 buildings, and output we have to see how they come 5, right? So guys, the first request is nothing but 0 comma 1. So that means our employee want to move or transfer from 0 building to 1 building, right? So you can see from 0 building to 1 building. So you can see this is nothing but we have represented by x, right? I hope you can see my color. So this is nothing but we can see this one, right? After that, one employee want to transfer from one building to 0 building. So from 1 to 0, here you can see this is nothing but we can say a, right? We have given the name nothing but a, 1 not a. We have to see this one, right? From 1 to 0, I hope you can see 1 to 0. That means from this is be nothing but b, right? Then 0 to 1, 0 to 1 again, 0 to 1, this is nothing but we have seen y, right? Then 1 to 2, 1 to 2 is nothing but e, this one a. Then 2 to 0 simple, 2 to 0 is nothing but you can see z, and 3 to 4 is nothing but we can say this one c, right? I hope it makes sense. So we have seen all the, we can say, employees name a, b. We have given us some randomly name, right? Now what we are going to do, we are going to say how many requests these requests can be possible, right? There are total 6 requests, right? So how many requests are achievable? So see, two people are this x want to go to this building one, right? Right, and one employee are moving from this building as well, right? That is nothing but b only. So you can see if we consider only this thing, that means it is achievable, right? One employee is going to this building and one employee coming to this building. So both is going to remain same. This employee X enter here and by let's say X come here, and an employee from this building B come to this building 0. So both remain same, right? Number of employees remain same. No any empty space, no any extra space, right? Fine. So we have achieved two requests so far. Now the next exam, next C, can we move Y here? So let's see that. One employee moving from 0 B, right? From 0 building, one employee moving to building 1, and one employee from building 1 also moving to building 2, and one employee from building 2 also moving to building 0. So if I just remove all these things now, because we have already seen X and Y, X and B, they have been gone, right? Now an employee is going from this building, fine, and moving to this building, right? So that means there is one extra space now, which should not be possible. So one employee, they are also moving to another building, to this one. So here now balance, because here one employee come and one employee went, right? So it is balanced out, right? So there is no extra space, no less space, right? So this is now completely fine. So here is one extra space, fine, and here is one less space because one employee went from this particular building, right? So we find there is one employee extra. So there is also one employee going from this building to this building 0. So that means one extra space was there, that has been now fine. It is, we can say there's a fixed number of rooms available, so fixed number of employees are there, right? So there is no extra space now, and one employee come to this building. So there was one less space because one employee went from this building. Now that also got full, right? So we can say now this circle has fulfilled all the buildings, right? So there is no, we can say number, we can say less number of rooms available, or an extra employee enter to any building. So they are completely we can say fulfilled, right? So we can say these three also can be possible: Y, A, and Z, right? So we can say 2 plus 3 is nothing but total 5. So we can say total 5 requests are achievable. Now let's move to the next. This is nothing but C only. So if we move any employee from this 3 building to 4, then one employee, this building will have one extra space, right? This building will have one extra employee, right? This employee should not be there, right? Because there is no extra space. These are already full. So any employee should also move from this building as well, right? But you can see that no employee are moving from this, so this request can't be achievable. So we can say total request is nothing but 5, which can be achievable. So you can see output as well 5. Now let's quickly move to the next example. Here guys, you can see one employee is moving from Y to this building 1 to building 2, and one employee is moving from building 2 to building 1. That means it is a neutral, so we can say it is possible. So Y and Z is already possible, 2 is possible. Now one employee is moving from 0 to 0, that is also possible, right? So we can say nothing but total is 3 is possible. So output is nothing but 3 only. I hope it makes sense, right? So this is how we can say the problem understanding part. I hope you understood the problem statement now, and you have seen the example as well. So I believe you must have a better understanding now in the problem statement. Now let's see how we can solve this problem. What is the logic to solve this problem, right? So for logic part, nothing guys, we are not gonna do much here because the logic is gonna be really simple. What we have to do, nothing, but we have to use all the combinations. Simple thing guys, we have to use all the possible states. So what I mean by here, see guys. So we have this array, right? 1000, this one, right? Let's write, or yes, I'm here gonna give a brief, not brief idea, just but little much idea so that you can understand what we are doing. Let me move all these things. So let me write here logic, and here I'm saying that 0, 1, 1, 0, 0, 1. There are also 1, 2, 2, 0. Last is nothing but 3, 4, right? So guys, this is nothing but our array, request array. So what we are going to do, we are going to say fine. You don't need to do any, just use a recursion. This is 0 indexes, 1 indexes, 2nd indexes, 3rd indexes, 4th indexes, 5th indexes, right? Now what we are going to do, we are going to use all the possible combinations or all the possible state. So first time we are just going to do this particular part. We are going to say fine, just do this particular request, right? Or I will say that just try to achieve this particular request only. So see whether you are getting we can say all the buildings are all now neutral or not, right? How we'll come to know that all the buildings are neutral, we will see that particular part later. But if we try to achieve this particular part and still a building is neutral, so we can say fine, that is a good case. So we can say this request is possible, right? And here if we are going to see this particular part now, we are going to say next possible state is nothing but try to do this like this. Is this achievable? If we do this both, fine, this is also possible. Then we are going to move to the next one. Is this achievable? Fine, this is also possible. Then we are going to move to this one. Means we are going to use all the combinations. I know you know what is the combinations. Means like all the combination which can be possible from this all possible 6 length of an array, right? So there could be a we can say 6. You can try auto combinations part. There are going to be more than that particular things, but we are going to use all the combinations from this 6. Or after that, we are going to check is this building, all the buildings are neutral or not. And for that, what we are going to do, check. We are going to create one array buildings. We are going to say fine. This year we have created an array of 5 length because there are 5 buildings. So initially, nothing but we can say there's all the values are 0, right? And these are nothing but indexes. On 0 index is value 0, 1 index value 0, second index value 0, third index value 0, fourth index value 0. Fine. Now what we are going to do, we are going to say if we are moving this using a first request. So you can see on 0 building, one person or one employee is going to one building, right? From 0 to 1. So on 0 building, we have to decrement by 1. We have to decrement by 1 because from 1% or one employee is moving from 0. So there is space left for one employee, right? And moving to which building? One building. So on 1, we are going to increment by 1 because there one extra employee came. So this can say that if we achieve this particular request, that means we can say we cannot getting all the buildings neutral. So we can say this is not possible. This is not achievable if we use this particular single request, right? Fine. And here if we take another request as well, here we are seeing that 1 to 0, right? That means one employee from 1 is moving to the 0. So that means one space is getting left for 1, right? An employee is moving from one building, so that means we have to reduce by 1. So from 1 on that one index we are reducing, so we are getting at 1 minus 1 0. And moving to which building? 0. So we have to increment there, so we are going to increment minus 1 plus 1 is that 1 0. So now if we see all the buildings are neutral, right? So we can say these two combined are achievable, right? So we can say these two are achievable, right? So we can say now total request is nothing but 2, which is achievable. So now to this we have to keep doing for all these. So we are going to do then this one, then this one. It's not like that we are doing with this only. We are going to separately also do with this one, with this one, and also with this one. Means we are going to use each and every possible combination, right? I know you, I hope now, I believe you know what is combination. If you don't, you can try searching on the Google. It's a small math concept, that combinations, right, which take all the possibilities, right? So that's all guys, we are going to do this particular part, and we're going to keep checking for each state of the combination whether it is neutral or not. If it is neutral, so we are going to return other one, otherwise we are going to return false, right? That means 0, right? So that's all we are going to do. Let's move to the implementation part. There you can easily understand what I mean by these combinations and what I mean by checking the neutral state for buildings. Everything you will get a better understanding with the implementation part. So let's move to the implementation, right? So here guys, first of all, I'm the Python. So what we are going to do, we are going to say, okay, define one function soul, and here index is nothing but tell us that which request you are taking right now. And after that, what you're going to do, you're going to say buildings, right? Fine. Here we are going to say if index is nothing but we can say length of request, right? Length of request. So what we are going to do, we are going to find if it is equal to that, we are going to say, okay, check all the buildings are we can say neutrals or not, right? So we are going to say if all and we can say here all value is equal to 0 for value in buildings. So this is how we are going to check if all the values are equal to 0 for value in buildings. So what we are going to do, we are going to say fine, you have to return nothing but return 0, otherwise you are going to return nothing but let's say infinity, right? Float infinity, which means negative value. That means this is not possible, right? And we have to write minus, let me write minus infinity. Fine. And this is done. If it is not equal to the length of request, that means we haven't processed all the requests. So we are going to move to the next request, and here we are going to check. First of all, let me use a here at the rate LRU cache. That is means nothing but we are memoize it, and for memoize it, we have to pass this building as a tuple. We can't pass a list because it is unhashable. So we are going to convert into a list. So we can say now new building is going to be nothing but list of. I'll tell you why I'm doing these things. Buildings. And here we are going to say now new buildings, right? What you're going to do, you're going to say request of that index of 0. Means it's going to tell us that from which building up any employee want to transfer, right? So we have to decrement by 1, isn't it? Okay, and same thing, new buildings of request of index of 1. That means to which building that particular employee want to move, right? So we have to increment by 1 because there is going to be one extra employee now, right? Once this is done, we are going to call this function again, right? But see, I have converted into a list, and then again I will pass into a tuple. Why? Because we can't, we can say change in tuples because tuple are immutable, right? And one more thing there, guys, we have used a new building variable just because we want to, but we want to use a knapsack like algorithm here. That means either take it or not take it, right? So here we are going to say either you have to process this request or you don't have to process this particular request, right? So we're going to say, okay, first time if you're processing this request, you have to increment by 1. That means this process, this request we have processed, and you're going to call this function same sort index plus 1, and buildings you are going to pass now new buildings, but you have to convert it into a tuple, new buildings, right? And same thing now we can say comma, no comma, we have to say this solve, don't we need to use solve, we have to use maximum here. So here comma we are going to say now either you have process it, either you don't have to process this particular request. So we are going to say solve same index plus 1, the building owner remains same, right? Buildings owner remains same. So this is what we are going to do. We are going to return this particular part. What happened to this? I don't know what is this. Right, so fine. Okay, here what we are going to do, we are going to say return this particular thing, right? Return this particular thing. I hope it makes sense, right? So that was the simple thing we are going to do. Now what we are going to do, we are going to say fine. We are going to call this function solve, and here we are going to say index is nothing but remain going to 0. Buildings we are going to say nothing but we let's pass this empty, so we can say tuple, and here we can say 0 into n, right? So this is nothing but we can say a buildings, right? Now we are going to return nothing but this building. So let's run this code. Let's see whether it's working fine or not, right? So you guys can see building spelling is mistake. So let's pass here building. Now let's run this code. You can see guys all the test case pass, right? So let's try to submit this code as well, whether it's working fine or no. I hope guys it should work, right? So you guys see that it successfully got submitted. So we have successfully solved with the Pythons, but we have done nothing but we have to use just all the combinations. So first time it will take, a second time it will also not take these things. So it's gonna use all the combination for this. And this is a next better way also, which we can see now with it, we can say, let's move to the Java now. And here what we are going to do, we are going to say fine. Let's define one function, right? So here first of all we are going to define one array, which is nothing but let's say give a name buildings. So there we have used a tuple of n size, but here we are going to find an array of buildings, which is going to be nothing but new int of let's say how many maximum request can be there, building can be there. So maximum building can be there. Let's see, maximum building can be there 20, right? So we can use at max 21, right? And we are going to use here 25, right? Just to make better, but here we can use also 21, which will also work because at max there could be 20, right? So 20 also will be possible, not 21. 20 will also be possible, right? Fine. Now what we are going to do, we are going to create one function that is nothing but solve, as we have seen in Python. Here we are going to say nothing but int n and int request, and here we are going to say index and nothing else, right? And here we are going to say if index is equal to request dot size, and here we are going to say if index is equal to request dot size, we are going to return nothing but what we are going to say count 0 in this buildings, right? So you have to pass here nothing but buildings. Building also you don't need to pass because it is globally variable. So what you can pass here, you can pass here n only, right? Fine. And here you have to say if count 0 is equal to we can say n, right? If it is equal to n, that means what you are going to say, you're going to say, or we can say, right, if it is a true, that means we can say return 0. Otherwise you have to return integer dot min value, right? Once this is done, we are going to say fine. If it is not the case, that what you are going to do, you are going to use all the combination, right? So you're going to say buildings of index, you can pass here, let me just pass here request of idx of 0, right? And here we have this one in decremented because employee is moving from this particular building. And next is nothing but buildings of request buildings, so we haven't used I here, right? And buildings of request of idx of 1, we have to increment this because an employee is moving to this particular building, right? After that we are going to call int result 1, which is going to be nothing but solve, and request is going to also remain same request, and here index you are going to increment it by 1, right? After this, once you have done this thing, you are going to do the same thing again. And why it is so? See guys, here what we are going to do, we are going to say fine, you have called this function for this particular case, right? So first time we have taken it, right? The second time you don't have to take this, right? So for that what we can do, we can say make this earlier how it was nothing but like this. We are going to say plus plus and minus minus, right? This become neutral, right? So we have first time incremented it, second time first time decremented it, second time we have incremented, right? So same thing is going to do for that building 1 as well. After that one this is done, we are going to call the same function again with the result 2 variable. So this is nothing but we can say didn't take, right? And this one we have take. So let's give a variable is there take, we can say no take, right? Fine, no take. Now once this is done, we are going to check return. You have to return math dot maximum. Either take, if you are taking it, then you have to add one, otherwise no take, right? So if it is a whatever the maximum value, that is going to return. After that, what we are going to do, we are going to call this function over here in this function maximum request. So we can say solve, n is going to remain same, request is also going to remain same, and index is going to 0, right? Now once this is done, we are going to say return this particular thing. Before that, we have to define one function that is nothing but count 0. So we can say public boolean and count 0, right? And here we are going to say int n, right? Now we are going to say for int I is equal to 0, I less than n, let me write n, and I plus plus. Here we are going to say if this particular buildings of I, and here if it is 0, then fine, you have to increment your count. So you can say count plus plus, or we can say okay fine, keep going, otherwise return false, right? So we can say return false if it is not equal to 0, right? Otherwise you have to keep return this loop. After that you have to return 0, right? Fine, now let's run this. So what we are doing here, this function just checking all the values in this building till n should have value 0. If it is not, then you have to return false, right? Cool. This is giving an error. What is that? This is solve function, right? So what is the return type here? Return type is going to be nothing but integer only, right? Let's run this code. So return solve. What we have done, we haven't given any space here. Let's see now. Hopefully it should pass, right? It should pass all the test cases. So let's see. You can see all the test cases pass. So let's try to submit this code as well. So by this we are going to submit with Java as well, and that's really cool. What we are doing, just we are taking and not taking it, and we are returning if that is possible, if building is neutral, right? Now let's move to the last note, third programming language, which is C++. And here, first of all, I'm going to divide one array. So let's say integer. The array name is buildings, and here buildings size is going to be 25, and this is empty, right? So by default, it take all the values in 0, right? So that's why we are not making it 0. Now we are going to say 4. No, 4. We are going to define here also one function, right? So we can say int sol. The function is going to take n, and then it's going to take this vector of request. So we can copy this only, right? So why to write this much code? Just copy all these things. So we can say fine. And here what we are going to do, we are going to say index. Fine. So here we are going to say if this is the case, if our n is equal to not n, we can say our index is equal to request dot size. If it is equal to this, then what we have to do, we have to check is all the values are equal to 0 or not. So we can say return count, and here we can pass our buildings dot size. We have to say begun, right? Or we can pass it directly here like this, begun buildings, right? Begun of buildings comma begun, not begun. We can say begun of buildings and plus n, right? Plus n. After that we have to check which one, 0. We have to count 0. If this is equal to n, then what you are going to do, you are going to return as 0. Otherwise you are going to return int min. Int min, right? If this is the case. So I hope you are getting this. If we reach to the last of the request, that means we are going to check if building is neutral or not. If it will be neutral always if all the values in the buildings array is going to be equal to 0 for our n buildings, right? After that we are going to say if it is not the case, then what you have to do, you have to increment by one. You have to increment and decrement from the, we can say employees moving to the employee moving, right? So which I means nothing but we have to increment that building where the employee moving, and we have to decrement that building where from where employee is moving, right? So here is from one to y relations. That means nothing but we can say buildings request of this index of 0. That means here the employee is moving from this building, the employee is moving, so we have to decrement this one, and we have to copy this one. I don't know why my shortcut is not working here. So what I'm saying that here, copy this thing, paste it over here, and here we have to increment it, but we have to take index of 1. That means the employee is moving to this building now. So once we have incremented this, what we are going to do, we are going to call the same function in take. Is going to be nothing but we can say call this function solve. Index n is going to remain same, request is going to remain same, and index is going to increment by 1. Fine. And after that again same thing we have to do. I copy this one, I pasted it, and here we have to not make it neutral, right? First time we have taken it, now we are not taking it, so we can say plus plus minus minus, and here we have to just call this function with a new variable that is no take, right? Once we have taken and no take, we have going to return maximum take comma non take, right? But see here guys, if we're taking it, then we have to increment by 1. That means we are able to resolve it, right? Now once this is done, we are going to call this function over here, solve, and is going to remain same, request is going to remain same, and index is going to be nothing but 0, and we have to return this one. Fine, now let's run this code and see whether it's working fine or not. And I hope guys it should also work, right? But not, it give a requested size. What is size? It's fine. We haven't used s variable, right? Do we have any more error? Let's see. So yeah, there's one more error, that is nothing but use of undeclared identifier int means. So we have used a small t. Do we have any more error? Let's see. So you guys can see that one more error, that is nothing but sol, which is nothing but we can say sol variable. So we can use like this, right? Now one more error, sol. Fine, we have copied this, right? So we can use like this. Now let's see. I hope now it should work, right? So here you can see guys, all the test case passed. So let's try to submit this code as well, right? With this, we gonna successfully solve with the C++ programming language. So you guys can see that it successfully got submitted. So we have successfully implemented with C++. Now let's move to the last programming language, which is nothing but JavaScript, right? So here guys, first of all, what we are going to do, we are going to say, first of all, let's say const building. Buildings is going to be nothing but new array of 5, right? No, 525. Now we are going to say 4, that I is equal to 0, I less than 25, and I plus plus. And here we are going to say if, not if, we are going to say buildings of this I, we have to make it 0, right? So we have make it 0. That means we have make initialize of 25 arrays, array with the default value of 0. That means there is no employee. All the buildings are neutral, right? We can say in simple terms. Now we are going to make a one function called sol, and that sol function is going to have one parameter index, and then we are going to say fine. Here you can say if, not if, we can say index is equal to request dot length, right? If it is equal to request dot length, we have to check count 0. We have to count 0, but for that we have to say count 0 for this particular n, or we can count here as well. So we can say 4, let I is equal to 0, I less than n, I plus plus. We can say just you can make let count variable, right? Or we can say directly here, if any of the building, if we can say buildings of this particular I is not equal to 0, then what we can return? We can simply return minus, let's say least minimum value. So we can say 4, 6, 7, 8, right? Fine. That means we are going to return this. Otherwise, if this loop over, that means all the buildings are equal to 0, that means this is neutral. So we are going to return at 0, right? And if index is not equal to request of length, then what we are going to do, we are going to either take it or not take it, that request. So we are going to say, if you're taking it, so you can say buildings. We have to use correct spellings, buildings of that particular request, of index of 0. We have to decrement it. And same thing we are going to copy. And here we are going to write a 1. We have to increment it, right? Once this is done, we are going to say let take. This take is going to be nothing but we can solve index plus 1. Fine. After that, same thing we are going to copy. I hope you are knowing what I am doing now. I am just making it neutral, and here after that I am calling the same function again, which means it is not take. Right. After that, we are going to return nothing but minimum one, not minimum, maximum. Return math dot max. If you are taking it, then increment by 1. Otherwise, not take. Then we are going to call this function sol. So let's call this function sol. Return sol with 0 index. Let's see whether it's working fine or not, right? So let's run this code. Do we have any error? You can see guys, all the test case passed, right? So we have successfully solved with JavaScript. So let's try to submit this code as well. Hopefully we should not get any error in submission part. So let's see. So finally guys, we also submitted with this JavaScript programming language as well. So I hope guys you understood the implementation part, what we are doing, just we are taking it or not taking it. And if you have any kind of doubt in the problem understanding part, logic part, implementation part, you can write in the comment section. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.